from here outward, but conventional current. Okay.
Yeah.
We imagine positive charge. So you know, I sometimes take my finger, and it goes through here, and this is just to measure it. And this doesn't affect the circuit in a sense. You know,
Yeah.
zeros of resistance.
Right.
It's like a wire.
Yeah.
And then it goes. Oh, is that the smell? Yeah. And then it goes through here, and then some of it goes through here, and some of it continues this way.
Right.
But it can, as you can see, it can get a little confusing. Now, the current that goes here eventually goes through this light bulb, and so therefore this is measuring the current through that light bulb.
Right.
The part of the current that goes here, you know, goes through here, goes through this light bulb. So this is measuring the current through that light bulb.
Right.
And this is measuring the total current coming out of the battery. So there's your parallel circuit.
Yeah.
Maybe I'll just leave this.
Yeah.
Maybe
Yeah.
just turn this off. Because I'd probably forget.
Yeah.
And that's the harder one for the kids. Now Tuesday is physics class. That's when we'll go back to the virtual and have them construct the parallel circuit. And they'll conclude that the voltage drop is the same across each resistor.
Right.
And that the total current is the sum of individual currents. Series circuit.
Namin sa eskwelahan ay nagkuhan sila kanin. Dari nagtulo ang atong husband sa high school. Mani lang periodic table of elements. Wala man sa mutla kining ko na wala kining sa. My God, mabuang ko ani periodic. Labi periodic ko.
Is take the meters away.
Periodic na,
And then just hook up the circuit. And then insert. Now the voltmeter is easy. You don't have to
Now
insert
periodic table.
Here's how I would do this with this series circuit real quick. Get that out of there. Get the meters out of there. And I'll insert them later. You know, but first I want to see it. You know. So this one goes through here.
High school.
Here, now I start this here. So it's one pack.
And experiment nila. I think Thursday na siguro or Friday. No, Friday ga wala may school on Friday. No school day pag Friday. Yeah. Nami ani. Ani. Katong periodic table mo. Wala ko kayo doon.
Now, you know, do you have to put, it's not even obvious, like if you put the ammeter, this one, you know, they always have it. They'll put the ammeter right here, and they'll say that's the current through this light bulb. Well, it's also the current in the battery, so how do you even distinguish it? It's so self-evident, in a way, that the current is the same no matter where you put it, that it's hardly even worth hooking up, but it would be easy to put a ammeter in there. Or right here. But, you know, which one is this measuring? The battery current or the current going through there? There comes a certain point where it's like, this is ridiculous. In other words, why would you say this is measuring the battery current and not the current through here? Well, you know, it's connected. Yes, it's the same. And the voltmeter thing, never have to hook up the meter. Because then it can get really confusing to the kids. Because you get these wires all over the place.
Right.
So that's why this thing comes in.
Like high school. There. Longboard area.
They might not think And if you turn the lights off, I wouldn't put it, we don't have before. And then I would just put this on 200. And there we go. This sort of encompasses like this. What's that read? 52.
2 volts.
And this one won't be reading. It's like this. It's not the same. Unless it happens to be the same. Well, I don't know.
19.
Right, okay, so that
Oh.
moves up. What's 52 plus 19?
So
71.
71.
That's what you should get. Roughly. Yeah. So for the series circuit, some of the voltage drops. And the current is the same. I wouldn't even, I mean, if you wanted to,
No,
you know, you could hook up an animator, but like I said, so it just don't. It's like less than 1.
see, man? Well, let me ask you this. Could you use ammeters in different connections to avoid using a voltmeter and figure out everything just using currents? Could you? I just wondered if you could.
Because of the, as you said, for a voltmeter, the internal impedance is like infinite. So no current actually goes through a voltmeter. The ammeter is just the opposite. The internal impedance is like 0. So in other words, that's what, you know, by connecting it in series, there's no voltage drop across the ammeter because it has 0 resistance.
Right.
So and all the current goes through the ammeter. And then it's one of Maxwell's equations actually. There's a magnet
Right.
and current in the wire. The wire will deflect. There's a little torsion, twisting. When you put a wire in a magnetic field, nothing will happen.
The current though is very tiny, I would imagine,
Go ahead.
right?
You mean the ionization current?
Yeah, no, but the actual current, machines like this basically, we have the electrostatic machines and it makes sparks. And you can smell something, Olivia, that's called ozone, it's a little gas, like oxygen,
that,
but it's a
huh?
little bit different. And it stinks,
So I'll tell you
but yeah,
what the voltage is.
yeah.
It does, I did look it up.
Oh, yeah.
3 times 10 to the 6 volts per meter. That's
Per
the
meter,
electric
that's a
field.
meter, it's-
Electric field.
right,
That's what it takes to ionize air, and that's what's happening.
okay, yeah.
So you could therefore, if that's not 1 meter, obviously,
Yeah,
yeah,
that's-
not much. There's not much. You know, I mean, in other words, it's not lethal.
No,
The machine itself isn't
right,
lethal.
not this one,
This one.
but also the current
This thing looks like a
is
Ferris
very
wheel.
tiny.
Yeah, go ahead.
No, but the current in this is just like, not even, you know,
Micro.
right, exactly, that's what I mean, yeah, microamp, so,
Because actually milliamps can throw your heart. I know that.
See?
Milliamps. It only takes milliamps.
Daddy,
A constant milliamp. If it's only for a billion
Stop,
seconds,
Daddy.
I can see it.
right,
Wow, look at
I've
the
gotten
nice
hit
video.
before in high voltage systems. And, you know, one time in particular at Rochester,
Electricity
I had to
is
sit
so
down.
pink. I mean, so
and
purple.
if I wasn't young, I don't know if I'd be here.
right,
You know, I made a
right,
mistake.
yeah,
That's why I have to be, you know, people should be
ahead.
careful with
Well,
electricity
okay.
because you can make a
yeah,
mistake.
yeah.
This is experiment.
You know,
Yeah,
when you're outside moving a wheelbarrow or something, you know, gravity's very forgiving,
right,
but if you make a mistake with electricity without thinking things through, you can die.
right. Well, in our books back there that you have, you know, the history book,
Yeah.
the guy who invented the capacitor, that's what happened to him. He got a huge shock.
Really?
And he was out for 3 days, and he said it almost killed him. So,
Oh, sure.
you know, this is static electricity.